Today's lesson is Chapter 10, Section 2, Describe the Likelihood of an Event. We do that through probability. So probability is a number between 0 and 1 that measures the likelihood an event will occur. If we say that the probability is the number 0, we're saying that's impossible. If we're saying it's the number 1, we're saying it is certain. Often, students think of probability in terms of percents, and that is okay. However, I just want to be very clear. Definition of probability is between 0 and 1. So to find the probability of an event, we use this simple formula. The probability of an event equals the number of favorable outcomes divided by the number of possible outcomes. And we do really use this notation, P for probability, parentheses, and we'll write in a word describing the event we're talking about. So let's see this in an example. Describe the likelihood of the event given its probability. The probability that you land a jump on a snowboard is, my 1/2 is out of the way. Sorry about that. That's a little awkward. I can move it on my paper. You're just gonna have to write it in on yours. When our directions ask us to describe the likelihood, it wants us to use a word, not a number. And those words we're going to choose from are impossible, unlikely, equally likely, likely, or certain. So the probability that you land a jump on a snowboard is 1/2. Well, that's exactly between 0, impossible, and 1, certain. So it is equally likely that you will land or not land. Problem number 2, same directions, describe the likelihood. There's a 100% chance that the temperature will be less than 120 degrees Fahrenheit tomorrow. 100% corresponds to that whole number 1, and we can say that it certainly will be less than 120 degrees Fahrenheit tomorrow. Problem number 3, on a number cube, what is the probability of rolling a number greater than 2? This problem is asking us to actually find the probability. We're no longer going to describe the likelihood. So I'm going to start just by writing this. P and then parenthesis, what is my favorable outcome greater than 2? So I'm going to do a little of symbolism. Instead of writing the word greater, I'm just going to write a greater than symbol, 2. And this is going to equal the number of favorable outcomes divided by total outcomes. And we can figure out each of these relatively simply just by analyzing our situation. We're rolling a number cube. Cubes have 6 sides, and those numbers are going to be, or those sides are going to be numbered 1 through 6. Our favorable outcomes are the outcomes greater than 2. And how many are there? Well, there's 3, 4, 5, and 6. That makes 4 favorable outcomes. And out of 6 total outcomes, because there are 6 sides on our dice. Just like always, with fractions, we need to leave them in simplest form. 4/6 is reducible to 2/3. So we can say that the probability of rolling a number greater than 2 is exactly 2/3. In the last example, what's the probability of rolling a 7? So I'm going to write P for probability of rolling a 7. Again, it's going to equal the number of favorable outcomes divided by the total number of outcomes. And in this case, it's kind of a trick question. What's the probability of rolling a 7 on a six-sided dice? Well, there is no 7 on a six-sided dice. So the number of favorable outcomes is 0. Our total outcomes is still 6, but we can reduce this fraction. 0 chances out of 6 is 0. It is impossible to roll a 7 when you're rolling a six-sided dice. Okay, number 5. The probability that you randomly draw a short straw from a group of 75 straws is 1 in 15. How many are short straws? I'm going to start in the same place just by writing P event equals favorable divided by total number of outcomes. And in this case, what we're looking for is the number of favorable outcomes. How many short straws are there? We know the probability of getting a short straw is 1/15. What we don't know is the number of short straws or favorable outcomes. So I'm going to use the variable x over the total. We knew that there were a total of 75 straws. And now we need to solve this equation. This is not just any equation. This is one of my favorite types of equations called a proportion, where we have a fraction that equals a fraction. I have a favorite method for solving such equations. It's called I-Hart proportions. The way it works, I start with 75 and I'm going to multiply it by 1. So I'm going to write on this side 75 times 1 and just multiply the diagonals. I do the same thing with the other diagonal, 15 times x, and this have an equal sign in the middle. And now we have one nice, easy equation that I can solve. 75 equals 15x. The reason I call it I-Hart proportions is obviously I drew a very pretty red heart. The red heart has nothing to do with the actual math. It just looks pretty and helps us keep our work straight. The reason this works is essentially what I'm doing is multiplying both sides by 75. It cancels on the right and shows up on the left. And I multiply both sides by 15. The 15 cancels on the left and shows up on the right. So to solve my equation, 75 equals 15x, I have one last step to get x by itself, and that's divide both sides by 15. 75 divided by 15 is 5. So we can conclude that there are 5 short straws.